Hi everybody, today we'll be going over Numpy crash course, so I think it'll incorporate everything which is needed for CFD, CAE, any kind of scientific programming and also machine learning as well. As you can see, we have loads to cover, so we'll just get into it. Okay, first of all we just need to import Numpy as NP, right? And first of all we must need to know what are the differences between Numpy and the normal lists. Okay, won't go into too much detail about this one because we don't really need just a theory bit. So for example, in case if you're just making normal lists, so you can have different data types and still it won't really be a problem. So like you can just put anything. You can also have list, you can also actually have an NT dictionary list inside dictionary inside a list, and so you can do all this kind of stuff with the normal Python lists. Whereas when you talk about NumPy arrays, they also look like lists, but basically how do you do that? So basically what you do, you say b equals to empty list. This is Pythonic list, okay? And in case if you want to make b as a NumPy list, so you just have to say array and then you pass b as an argument. Okay, so in case if you just want to see, okay, let's just print uh, type of a, right? And then on the next line we print can't type today, can I? Type b. Okay, let's see what's the difference. You see, the one is list, the other is NumPy. Now you're asking, why do we even need NumPy when we already have the same stuff going on inside the list? Well, lists are pretty slow when you, obviously it doesn't really matter at this point, but if you have large entries, and this is when it starts to pose a problem in the lists. While on the other hand, NumPys, they were basically designed to create homogeneous kind of containers, so all the entries would be same. For example, if you want to have int or float or stuff like that, like so you just need to have homogeneous stuff inside the NumPy array. Okay, so that's one bit. And initialization for the, I've already told you, for the 1D you can just do stuff like this. So in case if you just want to put 1 2 3 4 5, right? And if you wanted to print, you wanted to print b, okay, so you're just gonna get 1 2 3 4 5, right? In case if you wanted to go for 2D, so what you can do is you can say, okay, let me just copy this as well, see, put it here, okay, and then might wanna say, okay, let's do this, let's hold two elements, right? And the first element itself will hold another list. Okay, so this is your two-dimensional array, NumPy array. And if you want to see, then you can say b dot shape, right? Let's see what happens. Oops. List object, okay, b. All right, so we haven't really converted this into, one moment, so we haven't converted into NumPy array. So how do you do that? You just say b equals to np dot array, and then you pass in b. Okay, that's it, done, sorted. Okay, so now you're getting the shape, and in case if you wanted to get the dimension, so just gonna say ndim. Okay, let's see what happens now. Ndim, so it is telling you it is two-dimensional. Okay, and in case if you wanted to remove this bracket, that bracket, and that bracket, okay, and also this one. So what's gonna happen to the dimension now? It's gonna be just one. Yeah, you can see here 1. Now in case if you wanted to increase the dimensionality of the array, so this is what you do, like we had earlier, right? And then this is two-dimensional, right? And likewise you can also create three-dimensional in case if you just want to have, I don't know, let's just copy this, Control C, right? And then this is the inner one element and this is the second element, right? And then you can create inside this, you can again create, for example, like that, and then you do that. Okay, so that's gonna be your multi-dimensional array. It's a bit confusing, I know. So this is one element, this is your second element. So basically you're just holding 2D arrays, right? 2D arrays, and you're stacking them together. So this is 1, right? And then you just need to copy this stuff, Control C, and take away all that and do that. Okay, and now if you wanted to do, so you see this is three-dimensional. So this is how you initialize arrays. Yeah, next bit is shape and size. We've already covered, right? So let me just take this up, and now slicing, right? For slicing what you do, and in case somebody is hearing music in the background, just then I didn't want to bore you guys. Anyway, so for slicing, let's make another array. B is equal to, and then randomly 1 2 3 4 5, and then 33 43 42, some random numbers. Okay, and in case if I want to just print the length of b, right, that's gonna give you a length of b, but then again I need to make it as a numpy array, so I'm just gonna say numpy array and then pass it as b, right? So in case if we want to check, so the length is that, and it might probably want to comment these out. Okay, right. So now the thing is, I might probably, there'll be numerous number of occasions when you would just want to slice stuff. Okay, you might probably want just 3 and 4, you probably just want 42 43 and 42, you know, depending on your choice. So you would need to know actually what slicing is. Okay, and now for slicing you need to understand a couple of things. You just have to don't really have to understand, but you just have to keep in mind the slicing always starts from 0. Okay, so like Python, everything starts from 0, so this is the 0th element. Okay, so in case if I wanted just 2 and 3, how will I go about it? So I'll say, and now this is another area which you really need to take care of, or I'll get back to you. For multi-dimensional, let me just write it, multi-dim slicing. Okay, slicing. Okay, we'll get back to it, but now in case if I just wanted 2 and 3, so that is first element, right? That is first element, so I'm gonna be saying 1, and then I put colon like that, and then second element is your 3, but then you have to specify 3 here because this is exclusive, so it's not going to be taking 3. Okay, it won't take third element. So in case if you just wanted to, okay, let me see, am I printing anything below? Not really. So you copy this or cut this, yeah, we come here and we paste it. So this is how basically you slice, and then obviously because we haven't really printed this, so it's not gonna come out, so I'm gonna be printing this, yeah, and then we run it and we see we are getting 2 and 3. Okay, so this is single dimension. So slicing is a bit different when you come to higher dimensions, but don't worry about that. So what we can do is we can basically make it into a higher dimension. Okay, so like so. So we have 5 entries here and we have 5 entries there. That's okay. So now in case if I wanted to get this 2 and 3, now the thing is gonna be like so. Okay, so this is 2 dimensional because you have 2 lists, yeah, 2 arrays inside an array. So this is 2 dimensional. So now I just wanted 2 and 3. So how am I gonna go about it? Well, if you are working with Numpy arrays, then you have to have, so if you're working with Numpy arrays, so what you do, you say I'm going with the, this is second column, yeah, this is third column, this is fourth column, but this row is first row, right? So I just wanted first row, right? So I'm just gonna say like so, yeah, and then I wanted, so just say 0 here, don't worry, you say 0 row, and then you want second and third, so which is your 1 and 2, right? And then you say 1 comma 3, yeah. So now why I'm saying this is different to Pythonic way, let's just say, okay, just copy this, Control C, and then put it here, okay, and let's give it C, okay, and we are not making it as a Numpy array. So how you gonna be, so again, if I want 2 and 3, what I'm gonna be doing, I'm gonna be saying print C, and then you have to go out again. So this is the dimension, which you have. So in case if you want 0th row, right, and how many columns you want to go from 1 to 3, so this is the thing. So this is for the Pythonic, and this is for the Numpyonic. This is for the Numpy, okay, and it's gonna print the same stuff. Just gonna see, yeah. So that's basically what you need to understand as far as Numpy slicing is concerned, and this is for the Python slicing. So this is applicable to the lists. So I'm just gonna take this out away, and so I'm gonna take this away. So this is basically for slicing, and obviously you can do the same stuff for higher dimensions as well. But the main idea is that, you know, this one bit, when you're talking about the dimensions, so this one bit is basically telling this is 1 is the start, this is the end, and then you can obviously give the step size as well, but we are just giving step size of 1 here because we have a shorter list, and not really might probably want to do that. So how we do that, so we'll go by 5 and then we go step size of 2. Now before we run it, so what you're gonna be getting, so the first row, yeah, which is the 0th row, and then you're gonna go from 1 2 3 4 5, yeah. So basically 5 is exclusive, so you're going just with 4, and now you're giving a step size of 2, so which is where it's gonna be giving 1 and 3, and obviously because 4, that's not, we don't really have anything more. So in case if you want to print it, then we can do that. Let's see, not too many, oops, like so. So be very careful. So this is why you're getting 2 and 4. Well, this is what you have for slicing. Okay, now let's move on to negative indexing. Okay, this is also important, so I'll just keep, what I'll keep doing, let's just make another one. Okay, negative indexing. So we make another list. D is equal to I don't know, just put 3 4 5 6 7 3 4 5, right, like so, and then I'll have to convert it into np.array and then pass in D. So this is the basic procedure for converting anything into array, right? And now for slicing, in case if I just wanted to print, okay, I wanted to print these two numbers, yeah. So one way would be I'll be saying D, and then obviously you'll have to start calculating from here 0, 1, 2, 3, and so on. Rather than that, why not just go from the back, innit? So for going from the back, so all you just need to do is you're gonna be saying, okay, like so. And if I just wanted my minus, for example, if you just wanted 5, right, let's go step by step. So you just say 1, yeah. And if you want to print, that's gonna give you 5. That's okay. Okay, so you've got 5. In case if I wanted to go from -1 to -4, so that's gonna be like so. Sorry, -4. Yeah. So first element, second, third, and obviously this is exclusive. So you're just gonna go from 5, 4, 3. Yeah, like so. Oopsie daisy. You see this problem? Yeah. Basically, what you're trying to do is you're saying -1 to go to -4. So -4 position would be -1, -2, -3, -4, like here, right? But this doesn't work like that. Yeah, it's not as logical. Let me just write, take care of the direction. Okay, so you just can't move backwards. Okay, so you have to specify it like so. So you say -4, yeah, to -1, like so. So it has to be forward direction. Okay, now you won't have any problem. You see, this is what you really need to understand. Okay, so this is all about direction slicing. Now you'll say, bro, we needed to go up to 5, right? But the answer is not correct. Well, basically you just say, okay, like so. So -4, and then you just keep on going towards until the end, innit? So that's gonna give you 7, 3, 4, 5. So basically, whenever you're doing slicing, it's not as complicated, but you just need to take care of the direction. Okay, so if you're going from back to front, so that's another. So you're basically reversing, right? But in case if you just want these elements, so this is forward. So you just have to provide your stuff in such a way that it is forward moving, it's not backward moving. This is very important. Yeah. And also please do take care that even though when you're moving from front to when you're moving the positive direction, when you're moving from the positive in the positive direction, so it starts from 0, but when you're moving from the backwards negative direction, so this is -1. Okay, so this is -1, this is not -0. You don't have anything called -0, right? So minus in itself is telling you that we are talking about from the end. Okay, and how to get specific rows and columns and some combination of, we have already spoken about this up there. Yeah, like that. Okay, and then what do we have? Okay, how do we replace an element? So basically, let me just copy this. Okay, Control C, and we put it here. And now what I'm gonna do is I'll just give the location. So for example, if I want 5 to be changed to 99, so that is second location. And you guys say, no bro, this is third. No, this is 0, 1, 2. Okay, so second location, I'm just gonna put it as 99, right? And now in case if I just want to print D again, what's gonna happen? Yeah, so you're getting 99 here. So this is something which you really need to take care of. And while we are here, let me tell you, show you a magic. Okay, so now we have C. Okay, and C, you say, okay, put the content of D inside the C, right? And now you change C is hanging up. Oops, no. Okay, now you're saying put all the content of the array D inside the C, and then if you want to, let's just, okay, let me just copy this and let's put print C. Let's see what we get. See, you get exactly the same thing, yeah, because you are not using 99 anymore. But now what I'm gonna do is I'm gonna say do this C2, change it to 99, right? And then alongside with print C, we're also gonna do what we're gonna do, print D. Mind you, we haven't changed anything in the D, right? Let's try and run it. You see, C we exclusively changed, but D is already changed, right? So if you don't really want to do that, so you just have to say copy, and we have to make a D copy. So you do that, yeah, okay? So now won't be changed, yeah? So because D, you've made a copy of D. Otherwise what happens is, for example, this is when you say D equals to whatever you're saying, right? So this is just a reference, okay? This variable, this is not a container, this is just a reference. So when you say C equals to D, so C is also pointing to this stuff. So whenever you try and change anything from the reference, so that's going to be changing the content of the thing that is being referred to as well, okay? But when you make a copy, so that means you have made another copy, and now C is pointing to that copy, okay? So this is one thing which you need to take care of. What else? Can also replace a chunk with the same number. Yeah, basically what you can do is C2, for example, you're changing list, just do that, yeah. And if you're changing, okay, let's not do this copy thing, okay. So for example, if you want to change all of these stuff to one particular number, so you would have to say, well, let's go from one is inclusive, and then you go up till 4, right? So how many are there? 3, 6. Yo, 1 2 6. Okay, let's try and go 6. So basically you're going from 1 to 6 element, so that's not gonna go. You have to go up till 7, so that's gonna give you 4, right? So everything is gonna be changed in 1999 or 99 now. So this is how you can replace a chunk with the same number, right? What else is okay? Now comes the crucial part. So we're gonna be getting into random numbers, yeah. So obviously we have a third-party library called random, but we also have random numbers inside the NP. So I'm gonna be doing is I'm gonna be saying, okay, ref is equal to, so this is the just random name of the variable, right? So I'm gonna be saying np dot random, right, dot rand, just that, yeah. So what do you think? Just pause for a moment and think, well, what is it gonna give? So it's just gonna give you a kind of one value, which is just gonna be lying from 0 to 1. Okay, do you wanna check it? Let's do it. But we haven't printed it. Might as well have to print it. So we're just gonna be saying print ref. Okay, let's try and print it. What happens? You see? And if you do it again, it's gonna be a different number. If you do it again, it's gonna be a different number, because this is random stuff, right? But in case if you are providing, okay, I want, for example, let's try and put 6 here. Let's see what happens. So it's giving you 6 elements and it's creating your Numpy array, okay. And if you want to go for 2-dimensional, you might probably say 2,6. Yeah, that's completely fine. It's still gonna be random numbers, but these are float numbers, right? So you just have to take care about this stuff, right? So this is, so you might probably want just a scalar value. You might probably just want you know, a kind of a row array or a column array, or a combination of something. So this is how you do it. But now in case if you just want to go for integer types, how are you gonna do that? So rand int, let's try and do this. Okay, so what are you getting? You're just getting 3. Why do you just pause the video and just think? Okay, let's see how much you have thought. Let's try and do it again. Now you're getting 2, right? Now you're getting 5. So basically what's happening is you're specifying the start and the end, and you're saying just pick any random integer out of this. So this is basically but what in case if you want to say that we might want to go with a size of a matrix, yeah, and then size I might want to say 2,3. Be very just be very focused on this thing, yeah. What's happening? Look what's happening. 2,3. So you have 2 rows and you have 3 columns. That's okay. And now let's do some magic. Let's do this and see what happens now. What's going on? What's going on? Basically, it's just telling you, okay, you haven't specified, you just specified one number. So what I'm gonna be doing is I'm gonna be taking one number from my set, okay? So that number is 0. So you're saying computer is understanding, the NumPy is understanding. You're saying 0 to 6. Pick any random integer and make an array of the size 2,3. So that's exactly what's happening. So in case if you want to go with 60, for example, so it's gonna just pick random value from 0 to 60, and then you're gonna be having your array of size 2,3. Look, see for yourself. And just because it's random, so which is why every time it's gonna give you a different value. Well, that's pretty much about randoms. Yeah, float and integers it worked out. So this is for the integer value, and in case if you want to start from, if you have specific range in your mind, then you'll have to say, okay, this is your star, right? So that's your star, and then you have to define your stop or end. What is it? I can't remember, but I think it should be like that. Let's see if it works. Let's see. Not 0 will give it. Takes one positional argument. I think it is end. Okay, no problem. I just have to keep playing with this thing, yeah. And so in case if you want to do this, so basically what's the problem? So you do like so, right? But then this has to be made into rand range, okay? So that's exactly how you do it. No? Numpy rand range. What? Random.rand range, okay. Oopsie daisy. No, actually I'm going into, so yeah, exactly, this is how you do it. So you are correct, it was just the another parenthesis that's causing the problem. So basically you're low, you're high, and in case if you take this away, now with the same logic, so then it might drop below 60 as well, right? So you might want to check it, yeah, like so. So basically in case if you have a specific range, so you just have to say your low, the first one is going to be low entry, yeah, like so, and then second is your high entry, and then this is your size. So this is random, okay. I want to just double check it last time, like so. Yep. Okay, this is done. Now how do we repeat the values? So repeating values pretty much the same. Repeat np.repeat, right? So you have a is equal to 2 3 4 5 6 88, right? And then you want to make a b. Obviously you have to say a is equal to np dot array, and then a, right? And then you might want to say, okay, bb is equal to np dot repeat, and what's going to be repeated, a inside it, right? And then you might want to print what your bb. Let's see what happens. Numpy repeat. Okay, can't really spell to save my life today. What? np dot repeat. What's going on? One moment. Come on, man. How many times you want to repeat it? Probably 3 times. Should be good. See what happens. You see it like that. Okay. So what has happened? Can you see? Can't really see. Yeah. So this is basically it's just repeating every item of this thrice. Yeah. And if you want to stack it, there's a difference. If you want to stack, for example, if you just wanted to copy and then stack it and then stack it like so, there's another command. We'll go over that one as well now. So basically this is repeating, so you're just gonna be repeating individual, and in case if I wanted to make it 5, so then you're gonna see 588s at the end. Yeah, like so. Yeah, so keep in mind that. Okay, and then copying arrays, we've already done that. Arithmetic, so basically you just have any, just call it any, no, that's a keyword, so you called an1. Okay, so that's the name of the new name of the np array, np.array array, and then you might probably want to punch into 23 for 55 like so. Yeah, and then you might actually do what, no, you know what, let's make it 2-dimensional. Okay, let's make it 2-dimensional. That's okay. Let's copy this and have another one, Control V, and call it n2. Let's use these ones now. Yeah, 11 and 233. Okay, just to make them different. And now you can apply your basic arithmetic functions, right? So you can say a is equal to np dot sign of all the elements of an. So you don't have to specify the list. You just, when you say an1, so it's gonna take all the elements and it's gonna give you print a. Yeah, so that's how it's gonna be. Data type not understood. Oops, we forgot to make it, you see, because it is 2-dimensional, so you have to have outside pair of parentheses as well. Okay, well, these are the kind of problems and silly mistakes you're going to be encountering every now and then in your journey, so that's okay, but you have to be very quick in figuring it out. Anyway, so this is basically what you're getting for NP signs, and where you can do, I don't know, can, you know, you can do whatever you wish to. Yeah, and in case if you want to do sum, np.sum, what's gonna happen now? Yeah, let's see. So that's gonna give you 96y, because all these numbers, they sum up to 96. This is your arithmetic arrays, and obviously you can, like, you know, do the same kind the other functions as well. Once you get to the point, you'll understand what I'm saying. Okay, and now in case if you already have this, yeah, and if you were to say, okay, b is equal to an1 plus, if you was saying this an2, pause the video and think what's gonna be the output. Yeah, obviously, because we haven't really printed print b. Okay, let's see what's the output. So what's the output here? 1 and 11, 12, 23 and 233. That's going to 256. So basically, let me arrange them in such a way that you understand. So basically, just adding corresponding elements. So that's what's happening. Okay, might as well want to do negative. I don't know. Up to you, bro. Up to you. Yeah. So you have your negative as well. So in case if you want to do multiplication, you can do that as well. So 1 into 1, 11. So like so. You want to division. Just do whatever you wish to. Yeah. And you're getting 1, 1, 1 because you already have the same elements. So this is the kind of arithmetic operations which you can do, right? And then subtraction, division, multiplication done. Okay. And now comes the bit of a tricky bit. Yeah, tricky bit is like you guys must have worked with vectors. Now vectors, you might want to do dot product. Dot product is like corresponding values will be multiplied and then all of them together will be summed, right? So like for example, if you have two vectors a and b and then you do the dot product, so that's gonna give you, so in case if I wanted to do how exactly do we do dot product? So you say np dot 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 and then we pass in the n1 and 2, right? And might as well wanna print this, you know, like so. So what happened? 2 and 3 not aligned. What's not aligned? Yo, so we have to reduce the dimension. I'll tell you why. Basically like so, right? And if we do that, now it's fine. Yeah. And in case if I just wanted to have one, okay, let's suppose we just have one array, okay, like so, yeah, and then we had 3, 4, 5, and I copy this, Control C, take off everything, and then I do like so, yeah, and 2, right, and if I wanted to do np dot now there won't be any problem. Why? Because it's gonna be multiplying each corresponding value and then it will be doing 580, summing all of them together, right? When you're going into the two-dimensional stuff, so it's more of a matrix kind of multiplication. Now you might ask me, what's the difference? That's exactly what we're doing. No. Metric multiplication. So let me just do Control Z, like so. So we have 3 elements, 3 columns, and we have to have around 3 columns here. Okay, so I'm gonna be saying randomly this stuff. Okay, so 3 columns should be equal to number of rows. So number of columns, the first one should be equal to number of rows. So there won't be any problem at all, no matter what you do. Oops, my bad. You can't really divide. You see, there won't be any problem at all. So you just like, so your np dot that converts into your matrix multiplication. Yeah, so you just try and memorize these numbers. Okay, so let's just keep them there. What I'm gonna be doing is showing you something. So matmul is your matrix multiplication. So let's see if the numbers are different. No, they're not. They're exactly the same. So basically, so it depends upon the dimensionality. So you just need to understand that dot product is basically when you have 2 vectors and then you're trying to multiply a corresponding element and then you're getting them to add. That's basically matrix multiplication. So take away this stuff now, and min-max means some, well, I think they're pretty straightforward, so I wanna give you a couple of examples. So you can say print and then min, okay, you have to use np.min, and then you have to use an1. Okay, I want to print that, so you get minimum of 1, right? And you same way you can do max as well, right? So max is 55, so it's gonna throw 55, That's okay. Yeah, and you can have mean as well. So let's try and change the values a bit. So 1, 3, 4, 4, 8, right? And then 5, and then 3, and then 5 and 3, and then 12 here. Yeah. So what are you getting? So you're getting 15, 20, 24, 28, and then if you're trying to get for the mean, so you can 28 divided by 6, so we can get 4 point something. Yeah, so 4.66, so that's your mean there, and that's okay. And now some mean max we've already see. Okay, axis, that's important bit. So in case if you just want mean along the axis, so you might want to say axis is equal to 0. Yeah, so it's just gonna throw you a mean. So this is 8 divided by 3, that's gonna be 2.66 something. So it's just gonna be, oh, x is invalid. Okay, so yeah, shouldn't be a problem now. One moment. Okay, take that away, and then input dot mean, that's okay, should be fine now. Oh, come on, what is it unexpected while passing? Well, one moment, let's take the print stuff out for a moment, and then just say f is equal to, I think I'm visually impaired today, so let's try and print f now. Right, so this is what you're getting for np.mean axis 0. So axis 0 is your along the rows, right? So the first row, so you see the first, so you're getting along the rows. So first element of row 1 is 1, second is 12, sum is 13 divided by 2, 6.5, another is 3, 3, and then the mean is 3. So that's how it works. In case if you wanted to go for x is equal to 1, so that's gonna be along the columns, right? So 4, 4, 8, and then divided by 3, that's gonna be 2.66, and so on and so forth. Yeah, 2.66 and like so. And why just two values? Because we just have 2 rows, right? So that's how. Now next one, arrangement row. Now in case if we wanted to, let me just do it here only, right? Take away this stuff, take away this, and let's try and go for it stack. Okay, so in case if you wanted to stack these together, yeah, and you wanted to go for, you want to call it stack, okay, STA stands for stack. So I'm gonna be doing np.hstack, yeah. So I'm stacking them in the order of what, so I'll be stacking this and this, yeah, and because they have same number of columns, so let's do vertical stack. Okay, and column is, so what you're gonna do, en1 comma en2 comma x is equal to 1. I think it should work. What we said dispatch coordinates axis. So actually let's try and do it for x is 0. Shouldn't be a problem. What? Okay, one moment. So what you can do is just take away, because obviously you're specifying that this is a vertical stack. So what you might want to do is just like so. Oh, come on. I think this has to do something with the parentheses. Yeah. And then you might wanna print stat. Okay. So you see 1, 3, 4, 12 that, and then all that. Okay. And then you might wanna say axis is equal to rows. So I think shouldn't be a problem. We stack this watcher. See? So you can't really use axis because you're already saying v stack, right? And in case if you do h stack, that's gonna cause you another problem now. You see? Tell you why. See? Because the dimensions, you can't really stack them together because the dimensions are not same, right? So what you might want to do is you might want to just take away the third dimension. So now that should be fine. So you can set them right. So it should be okay. So you see 1, 3, 4, and then 11, 20, 233 and all that. Yeah. So that's how your stacking works really. Yeah. I think that's pretty much it. Is there any how many MinMax? Yeah. That's it. And the next one we might cover advanced stuff, advanced Numpy, but I think you should be able to get by pretty nicely with all these things that you have learned now or refreshed. And we'll see you in the next one. Thank you. Bye. Take care.